Alright, so I'm going to talk about these sequences in general, these series. So, with a geometric series, you've got to think about what's going to happen on your assessment and when you're sitting down to do your external exam. That's one of the main things going to be about. Is this the only sequence we've learned? What's the other one? Yeah, arithmetic. So how can we differentiate between this, the geometric sequence, and an arithmetic sequence?
This one you multiply arithmetic.
Yeah, so very good. So whenever you get a problem, it's probably not going to say geometric sequence or arithmetic sequence. It's probably just going to say, here is a sequence of numbers. So the first thing we need to be able to do is identify whether we have, or what type of sequence we have. What's a test we can do? What's a test we can do to decide whether we've got, or which type of sequence we've got?
Grab some numbers and minus by each other.
Yep, so you can grab preceding terms in a sequence and subtract them from each other. And what are you looking for? Yeah, pattern. You're looking for the same number, correct? If that doesn't work, you haven't got an arithmetic sequence, what should you do? What should you do? Divide them. So divide the second term by the first term. Then divide the third term by the second term. Then divide the fourth term by the third term. Once you've done that, what should you see? What should you see? A common ratio, correct? A common factor, a common value should be appearing. So that's how we can differentiate between the two. How will the growth look? Just with your hands, everyone in the room is going to put pens out of your hands. I want you to show me how an arithmetic sequence growth will look. With one hand. What should I be seeing? What should I be seeing? So you're doing the old hip to, BGs. Should be a straight line, correct? Happy with that? How should our geometric sequence look? It's more of a Ryan's dance move. Keeps it low, then flies it up. Is that it? What happens? Is that what all geometric sequences will look like? Who can think of a scenario where that wouldn't be the case?
When your ratio is
Yes, Tom? When your ratio is negative, how's that going to look? Correct? It'll get more negative as you go along? Or will it?
no.
Ah, very good. Harry thinks it's going to do this. Is he right?
Yeah.
And the distance will increase or decrease depending on what? So let's say we've got a negative number and it's like 2. What's going to happen? Let's start with 1. It's going to go negative 2, positive 4, negative 8, positive 16, correct? It's going to get bigger and bigger and bigger. What happens if our R was instead negative a half? First number? 1 times negative a half is? Negative a half times negative a half is? Positive a quarter. So it's going to start doing this, and it's going to get smaller and smaller and smaller. So when we did this, were we correct all the time? What were we talking about?
When R is more than 1.
When R is greater than 1 and when our first term is positive, correct? So just be aware of that. We need to be aware of the way the different sequences can look. Once we get to that point, once we know what type of sequence we're dealing with and we've identified we can use our term, we went through that last lesson, just in case we can't remember, the term, the nth term is equal to the first term times the ratio to the power of n minus 1. Why is it n minus 1?
Because in your operation you already have the first term.
Already got the first term, correct? I don't need to redo it. So when n is 2, I'll get t1 times r. When n is 3, I'll get t1 times r squared. Make sense? Can we have decimal number of n's? Or does it have to be a whole integer? Has to be a whole integer. And what else should we see? Given that t1's here, what should we see? Well, actually, you can deal with negative n, so I'll leave that there. Don't need to talk about that. Sweet. So let's talk about geometric sequence now. I've thought about showing us how this equation was divulged, but I'm going to cheat a little bit. Why am I going to cheat? You get one of these, hey? So what we really need to be able to do is not create a formula for ourselves. What we need to be able to do is identify whether it's a geometric sequence, whether it's not. Once we know it's a geometric sequence and it's asking us to find the summation, we then have to pick the right formula. So picking the right formula is a little bit tricky because we have two formulas. What's the difference between the top and the bottom formula? You wouldn't be using your calculator or your pens because you'll get time to write down in a second. What's the difference between the top formula and the bottom formula? The R and the 1. Swap over on just the bottom and the top. So we use this formula when R is less than 1, and we use this formula when R is greater than 1. Who thinks they're going to forget that? Because on your formula sheet you don't get two formulas, you only get one. The formula you get is, I had it before, is this one. No, it's not. It's this one. I lied. It's this one. So what do you need to remember? What do you need to remember? So how can we have a little... Because I will forget that. If I sit in an exam, I know I'll forget that. So rather than remembering this, I just need to know it's going to have 1 minus r to the power of n, or 1 r n to the power of r to the power of n minus 1 on the top and the opposite on the bottom. The bigger value goes first. So which is bigger in this equation, 1 or 1r?
1.
Which is bigger in this equation, r or my 1? So whichever value is bigger goes first, and the power of n is on the top r. But that you don't remember that because that's already in your formula. Cool? Happy with that?
Yeah.
That's the only shortcut I'm going to give you all year. Because normally I like to give you the formula and how it's developed, but I figure as we're pretty close to the exam and you've got one of these bad boys, we don't need to develop that. Clear? In a few minutes I'm going to talk about what happens when we sum to infinity, but in this case we just let n equal whatever term we're trying to sum towards. Cool. I'll let you keep going with that. We're going to do some more exercises that rely on that. Question 4 is the first part of that, so if you're up to there, keep going.